Topic is about the heating effect of current, and this is from the current electricity, right? In current electricity, mainly we study the effect of a charge moving in the wires. So when the charge is moving, then how it is contributing for the current and how it is heating up the wires, how the flow of current, how the flow of electrons that heat up the wire, right? So the today's topic, they are static charges and its field. Before going to this topic, we have to just go for a background knowledge, right? So for the background knowledge, the first topic is static charge and its field, and then moving charge and its field, and how radiations are produced by moving charges, and moving charges in the metal and wires and their effect on the atoms, right? In the atoms of the metals, how the moving charges they affect. And then electrostatic potential and the electric field. Actually, this is the relation between the potential and the electric field. And then concept of resistance in the wire, concept of resistance, concept of resistor also. Resistance and resistor. Concept of resistor. And then Ohm's law, finally, right? So these are the subtopics which I will try to cover in this chapter, right? So let me start with the background knowledge, static charge and its field, right? So you know that if we have a charge at rest, static charge at rest, so if we have is charge, suppose it is a positive charge, you know there is an electric field around this positive charge, right? Electric field of a point charge, that is a radial electric field emitting out. So electric field is a vector quantity represented by the capital E and then vector only, right? Likewise, if we take a negative charge, the electric lines, they will go inside, right? Radial inside, they will try to move towards it, and this is the electric field, right? This is the electric field of a positive charge, this is the electric field of a negative charge, right? And if we have a distribution of charge, for a distribution of charge, all the charges they are in rest, again by using the same concept, we can show the electric patterns, right? And if we have a dipole, means a combination of a positive and negative charge, then how we can show the electric lines, they will come out from the positive charge, right? And they will enter into the negative charge. So they will move from positive to negative like this, positive to negative. Right? But this is the electric field again, electric field. These two charges again, they are two charges, one is positive and other is negative. They are separated by a certain distance, and if we assume the distance is 2L, they are separated by a certain distance. Then this is a dipole, right? Having dipole means one positive, one negative. So this is the electric field of a dipole, right? These are the monocharges, and this is a dipole charge, means the combination of two charges. So this is the electric pattern. But only the electric field is there. There is no any other thing. There is no any other field for a static charge. But if the same charge, start accelerating, then what happens? If same charge, suppose this positive charge, it start accelerating, and the acceleration is A, then it carries two types of field. One is the electric field, already that is the natural property of a charge. It will carry the electric field, and then it will carry the magnetic field. So it will carry two types of charges along with. So accelerating charge, that carries two types of field, electric field and a magnetic field, right? But a static charge carries only the electric field, right? But here the acceleration is there and the speed is not so high, speed is low, right? Speed is low, right? Acceleration is small, speed is low, so electric field and the magnetic field. But if in the third case, if I accelerate the charge with very high speed, right? So when speed of the charged particle, that becomes comparable to the speed of light, So in that case, the charged particle that will accelerate or that will move with a speed v comparable to c In that case, the electric field will be there, the magnetic field will be there along with the radiations. Along with the radiation. Radiations means electromagnetic radiations. Electromagnetic radiations. So a moving charge, when it is moving with a small acceleration, with a small speed, then it carries electric and magnetic field. But when the same charge is moving with a speed comparable to the speed of light, then it will carry electric field, magnetic field, and electromagnetic radiations. Three things, right? So, so when the charge is moving with a very high speed, it carries a third part, which is not the field, that is the radiations or electromagnetic radiations. So now question is, if electric field is produced, that's clear. It's a property of a static charge, right? And if magnetic field is produced, again it is clear the charge is moving and there is additional field. But the question is how the electromagnetic radiations or the electromagnetic field is produced by a moving charge. So, if we focus on this part, the electric and magnetic part, this electric and magnetic part, right? So for a moving charge, when the charge is moving, when this charge is moving, suppose it is a positive charge and this is moving. So it means the field is also moving. The field is also moving, right? So the field is also moving, electric field as well as magnetic field. Both the fields are moving, right? So let me show the magnetic field also. Suppose this is the magnetic field. Magnetic field I will show by the cross. Okay, so because magnetic field is perpendicular to the electric field, right? So the field is also moving, right? Electric field and magnetic field both are there and the charge is moving, so the field are moving. If the charge changes its direction, right? Suppose the charge changes its direction, so what happens? By changing its direction, it will disturb both electric and magnetic field, right? By the change in direction, there is a disturbance in the electric and magnetic field, right? If there is a change in direction, right? So there is a disturbance in electric and magnetic field. That disturbance in electric and magnetic field that produce the radiations, right? So disturbance in electric field and magnetic field by moving charge produces electromagnetic radiations, right? So now the question is that if the charge is not changing the direction and it is moving with a very high speed, so what will happen? So if the charge is moving with a very high speed and if it is not changing the direction, then even in that case also radiations are produced, right? Because you see these are vectors. So in the vectors, electric lines, electric field is perpendicular to magnetic field. This is electric field and the magnetic field is perpendicular to that. So you see again the two vector and the charge particle that is crossing these. So it means already the charge particle that is disturbing the two vectors, and when these two vectors they will be disturbed, their direction will change automatically, right? You see that the charge particle is moving, right? And this is the electric field and this is the magnetic field, right? So automatically the direction of the electric and magnetic field by the disturbance automatically that is changed. So finally, in a nutshell, we can say that electromagnetic radiations, they are produced by the disturbance in electric and magnetic field due to the moving charge. The moving charge that will disturb the two vectors, electric and magnetic vectors, and due to that disturbance, we will get a electromagnetic radiation, right? So static charge that produces the electric field, moving charge that produces a magnetic field, and how radiations are produced? Radiations are produced basically by the disturbance produced by the electric field. Now in the fourth part, moving charge in the metal and wires and their effect on the atoms, right? So now let me start. This is the background knowledge, and let me come to the main topic, heating effect of current, right? Heating effect of the current. So let me take a conductor. So assume this is a conductor. This is a conductor having large number of free electrons. This is a conductor having large number of free electrons, having free electrons, How many free electrons are there? 10 raised to the power 28 electrons per meter cube in the metals, right? So the metal piece, the wire having 10 raised to the power 28 electrons per meter cube, and if the electrons are moving, right, they are moving. So if they are moving without any external potential, then the net current is zero. You know, net current is zero. There is no current, net current is zero, right, because of the random direction. But if I apply some potential, right, if I apply some potential, and this is the potential V, this is the potential V. So now what will happen? The electron, they start moving. Suppose this is the positive, and this is negative. So the electron, they will start moving from negative to positive, right? Negative to positive. So now what happens? This is not a smooth journey for the electrons. This is not a straight line path. This is not a comfortable path for the electrons. While moving from the negative side to the positive sides, now what happens? So moving charges in the metal wires and their effect on the atoms. So in the material, we have loads of atoms, right? And the loads of electrons. How many electrons? 10 to the power 28 electrons. And nearly about the same number of atoms, 10 raised to the power 28 atoms per meter cube. So now, while moving from negative side to the positive side, each electron will collide with the atoms, right? So you see, now this potential that produces an electric field, right, from positive to negative. So due to this potential, the electric field is established, right? This potential, and this is positive, this is negative. So this potential established the electric field, right? Electric field, and the direction of electric field is from positive to the negative, right? So electrons are moving from negative to the positive. Electric field is from the positive to the negative, right? So what the electric field is doing? Actually, electric field is accelerating the electrons, right? Electric field is accelerating the electron from negative to the positive. Mika, everyone clear? What the electric field is doing, what this potential is doing, right? This is the positive side, this is the negative side. So the electron, they will accelerate toward the positive side, right? So what electric field is doing, what potential is doing? So this electric field or the potential, what they are doing, they are accelerating the electron. So you see electron that is accelerated. They are accelerated electron. And the accelerated electrons means they acquire the kinetic energy, right? So they acquire kinetic energy, right? And with that kinetic energy, they collide with the atom, right? They collide with the atom. So let me take the example of one accelerated electron having some kinetic energy. With that kinetic energy, it strikes the atom, right? So when it strikes the atom, it collides with the atom. So that is an inelastic collision, right? So the electron will collide here, and this is the point of inelastic collision. Inelastic collision means maximum kinetic energy carried by the electron is transferred to the atom, right? If it is an elastic collision. In elastic collision means the electron will strike, but it will not transfer the energy to the atom. If it is an elastic collision. In elastic collision, there is no transfer of energy from the electron to the atom. But here, the collision is inelastic. Means there is a transfer of energy from the electron to the atom.
All the energy?
Maximum energy. With little energy, it again moves and it changes the direction. After colliding with the atom, now with little energy, the electron will again start moving. And again by the electric field, it is accelerated. Again it is accelerated. Again it is accelerated by the electric field. Again it will collide with the atom. Again it will be inelastic collision. Again it will be inelastic collision. Right? And again it will transfer its maximum kinetic energy to the atom. So each electron is doing the same thing. You see, electric field and the potential, they are accelerating the electrons. So we can say we have 10 raised to the power 20 electrons. So this is for the one electron, assume this is for the second electron, and this process keeps going on for all the electrons. So they start moving, they start accelerating, they acquire the kinetic energy, they collide with the atoms, they transfer the kinetic energy, right? So now you see the atoms, each atom that is acquiring the kinetic energy, right? So macroscopically we can say each atom get heated, right? Because each atom is acquiring the kinetic energy. So macroscopically we can say there is a rise in temperature of the atom, right? Or macroscopically we can say there is a rise in the temperature of whole of the material, rise in temperature of the whole of the wire, rise in the temperature of the whole of the metal wire. So this is the reason how the moving electrons, they heat up the wire, right? It is due to inelastic collisions happening with the atoms, right? So in that inelastic collision, there is a transfer of kinetic energy from the electron to the atom, right? So the most of the electron, they participate in transferring the energy to the atoms. So finally that kinetic energy that heat up the atom, right? So this is the reason how the metal wires, they get heated, right? So next part is electrostatic potential and electric field. So already I took the potential and electric field. So when there is a potential, then there is electric field. The electric field is the outcome of the potential difference. If we apply the potential difference, then there is the electric field. And this electric field that accelerates the electrons. What is the job of the electric field? The job of the electric field is to accelerate the electron, right? Right? There is one more concept. What is the job of the magnetic field? The job of the magnetic field is to confine the electron in a circular path, right? Electric field accelerates the electron, and if magnetic field is applied on the electrons, so the electrons they start moving in a circular path, right? So electric field that provides the linear acceleration, and the magnetic field that provides the angular acceleration, right? That moves the charged particle in a circular path. Okay, and the potential that produces the electric field. Now the concept of a resistance or resistor, right? What is the concept of resistance? So the concept of resistance again we will understand in terms of the potential. Now again, if I take a conductor or a metal wire, in the metal wire, if the potential is there, right? So what will happen? Suppose the electrons, they are moving, this is positive and this is negative, electrons are moving from negative to positive, so the current that will move from positive to negative, right? So due to this due to this potential difference, we are getting a current, right? Now if we do one experiment, again if I take a different material, so this is suppose some material A, this is one material A, and suppose this is copper, right? This is copper, right? And if I choose a different material, suppose the different material, suppose length is L and the cross-sectional area is A. With the same length L and the same cross-sectional area A, if I choose a different material, suppose this is silver, and I apply the same potential V. Under the same potential, under the same volume, means volume is A into L, right? So same volume is equal to area into length. So volume of copper and volume of silver, they are same. So this is the volume of copper and this is volume of silver. If they are kept same and voltage is also kept same, so how we will correlate the current in the copper and current in the silver? So under the same voltage and under the same dimensions, under the same volume, the current will be different. The current will be different. So this I and this I dash, they will be different. Why they will be different? So that we can understand in terms of resistance. Because this wire has a different resistance and this wire has a different resistance. Due to the difference in the resistance, their currents are different, right? So under the same potential difference, under the same dimensions, under the same volume, if the two different materials they give two different currents, then the reason is their difference in the resistance. So actually, what is a resistance? What is a resistance? So how much current is produced in a wire under the potential, that defines its resistance. So we can say R is equal to V divided by I. What is the resistance? Under potential V, if current is I, then the ratio of these two that will define the resistance. The unit of volt, V is volt, and this is in ampere, current is in ampere, and the ratio of volt and ampere, that is known as ohms. Ohms. Right? And the relation between V and I is that V is directly proportional to I. If there is any change in the voltage, correspondingly same change will be there in the current, and this is known as Ohm's law. Right? And if we remove this proportionality sign, then we can say V is equal to R into I, where R is a constant of proportionality here. Mathematically, what is R? Mathematically, R is a constant which correlate the voltage and current. How the current changes? By changing the voltage in a wire, right? So change in current and the change in voltage, mathematically they are related to a constant, and that constant again, that is a resistance. So you can explain the resistance physically. Physically means under the same voltage and the same volume, how the two different materials they produce two different currents, right? So that is due to their difference in the resistance, because the different materials they have different resistance, right? Different materials they have different atomic structures, right? The behavior of the electron is different. The inelastic collision, the acceleration, right? Everything is different, right? That's why the heating effect is also different. The heating effect of the copper, they are different they are different than that of the silver or any other material, right? So the collisions, the transfer of energy, right? Everything is different of different materials. So that's why the resistance of different materials that is different, right? And mathematically, if we or experimentally, the current that follows the voltage. If there is any jump in the voltage, any increase in the voltage, that will give the corresponding increase in the current. So that is known as the Ohm's law, right? And the unit of this R is ohm. So now, what do you mean by 1 ohm, right? So 1 ohm, so from this formula, R is equal to V upon I. If we want to define the 1 ohm, then this will be 1 volt and divided by 1 ampere. 1 ampere. So what is 1 ohm? 1 ohm is the resistance in the path of current when the potential difference at the two end of a conductor is 1 volt. Right? What is 1 ohm? 1 ohm is the resistance for a current of 1 ampere when there is a potential difference of 1 volt at the two end of the conductor. Okay? Okay.